All right. So in this question, it says without using a calculator, solve this equation. That means we have to find the value of W. So let's write W squared equals divide iota here, expand the numerator, we get A squared minus 2AB, that is going to be 8 iota, plus iota, b squared. So it's going to be 2 iota whole square, which is going to be negative 4. So we write negative 4 here. So we get just negative 8 here after cancellation. And now we square root both sides, plus minus square root of minus 8. This gives us plus minus square root of 8. We can write it as square root of 8 into square root of negative 1, and square root of negative 1 is iota. So iota, or we may also simplify this to 2 under root 2 iota. So this is what W is equals to. Okay. Part B1, sketch an argon diagram showing the region R consisting of points representing the complex number this. Okay, this means we have to draw a circle which has a center of 4, 4 and a radius of 2. For the center, we flip these signs. Okay, so B1 would be an argon diagram. Center is 4, 4. So 1, 2, 3, 4. 1, 2, 3, 4. This could be that center, and radius is 2. So we go here and 2 up and 2 down. So this would roughly be the circle. Something like this. If this is 4 and this is 4, we have 6 here, and we have a 2 here, and we have a 2 here and a 6 here. Okay. Part 1 is done. We've drawn the desired circle. Okay. Next part says for the complex number represented by points in the region R. Oh no, we have to shade it as well, because it says it's less than and equals to 2, not equals to 2. So we shade the entire circle, and we need to make the circle as a solid line because it's less than and equals to. If it were just less than, we would have made a dotted circle. Okay, back to part 2. For the complex number represented by the points in region R, it is given that modulus of Z goes from Q to P. That means the smallest value of modulus of Z in this shaded region is P, and the highest value of modulus of Z is Q. So modulus of Z again is the distance with any of the complex numbers in the yellow region from the origin. So this would be the modulus for the center of the circle. And if we choose a point here, this would be the modulus for that point. And if we choose a point here, then this is the modulus for this point. Now we have to find the maximum possible modulus we can find in the yellow region and the minimum possible modulus. Now, minimum possible modulus is going to be this line, and the maximum possible modulus is going to be, in fact, this line. So we have to find both these lengths. Let's start with the black one. So for the black one, we know that this length starting from the center all the way till origin is going to be square root of uh, 4 square plus 4 square, because this is 4 and this is 4. So that's going to be square root of 4 square plus 4 square. What is that equals to? That's just square root of 32. Let's write square root of 32. So this full length from the center to the origin is square root of 32. All right. And we subtract the radius from it, radius was 2. So the minimum modulus is square root of 32 minus 2. We'll find its value in decimal because it says give the answer in three significant figures. All right. And the highest modulus would be this length, which is square root of 32 plus another 2. So this would be, Q would be square root of 32 plus 2. Okay, let's find these out in decimals, and that would be our final answer. Under root 32 minus 2, that's 3.6568. We need it in three significant figures, so we're going to write, let me clear this. We will write 3.66. No, they want three significant figures. Yeah. So less than and equals to modulus of z, less than and equals to 7.66 after rounding. Okay. So we gotten under root 32 minus 2 for P and under root 32 plus 2 for Q, and we have that in three significant figures. This is the answer for P and this is the answer for Q. Okay. Next is that the argument of Z, and Z are all the complex numbers on the shaded in yellow. So we need to find the minimum possible argument of Z and maximum possible argument of Z. So for that, we choose a point which gives the smallest argument and which gives the greatest argument. Okay, so argument is the angle made from the origin to that respective point. So whatever this point is, this has the smallest argument. Okay, and whatever this point is, it has the greatest argument. So we have to find both the angles. This angle, which will give us the value of A, and this angle, which will give us the value of. Okay, so for that, we will need to apply a lot of trigonometry. Let's see what do we need. Okay, so we already know that the distance from origin to the center is under root 32. That was already found. So this is under root 32. Then this is the radius, which was 2. And this is going to be a right angle because tangent and radius are perpendicular. Similarly here, this would be 2, and that's a right angle. Okay, now how do we find the respective angles? Okay, so we can find both these inner angles, this one and this one. So we're going to use trigonometry here. Let's do that on the side first. So some sine theta for the first one, sine theta is equals to opposite over hypotenuse. So what will this be? Equals to shift sine 2 over under root 32. That gives us 0.3613, 3614 after rounding. All right, now let's find the other angle, which is going to be, we can use sine again. Sorry about that. Okay, so we will use sine again. So it's going to be the same size actually. So we can tell it's also going to be 0.3614. So this angle is going to be the same. Okay, now how do we find the arguments? Okay, so we need this angle right here. That's going to be the smallest argument. So what we'll do here is that we're going to make another triangle. What if we make a straight line down like this? I'll make a dotted one like this and find this whole angle and then subtract the blue angle from it. That will give us the smallest argument, that is this angle. Okay, so let's use this. I'm going to draw this separately. So if I'm drawing the dotted triangle, this is under root 32 and this here is 4. In fact, this is 4 as well. So this is going to be tan inverse 4 over 4, which is pi over 4. So theta is equals to tan inverse 4 over 4, which is tan inverse 1, which is, I know, 45 degrees, which is pi by 4. So this full angle is pi by 4. Subtract the blue angle from it, so pi by 4 minus 0.3614 gives us 0.42403. Okay, so that is going to be this least value of the argument, which is A. So A is equals to this. Next, we need the biggest argument, and we had already seen that this would be the biggest argument. So we already know pi by 4 and add the red angle to it, and that will give us the biggest argument. So it's just going to be pi by 4 plus 0.3614, which gives 0. In fact, 1.14675, which is going to be the value for B. So argument of C starts from 0.424 in 3 significant figures and goes till 1.15. This is A and that's B.